Fantastic. Thank you so much. My young nephew who's watching online thinks it's amazing that I'm chairing a panel following the poop session. So I'm never, ever going to top that. So thank you so much. You have made his day. He's majoring in sustainability in college, and he just thinks this is fantastic. So we're here to talk about remote sensing, climate, and methane. And I just wanted to start by saying, we used to have local environmental problems, which we still have, but, lead and water. We've had regional environmental problems like air pollution. And now we have international environmental problems like ozone depletion and climate change. And climate is complicated, right? Because there's multiple point sources, it's global, the gases are invisible. And so we're the trust but verify panel, right? And so I have two incredible experts here to talk about how are we going to monitor and review and verify these emissions from all these multiple point sources from around the world, because countries and governments have come together now in this incredible pledge to try to reduce methane emissions 30% by 2030. But how are we going to know that that's happened? So I have two incredible speakers. First is the president and CEO of GHGSat, founded in 2011. They're in the air now. They're looking at emissions to talk about this sort of new wave of satellite platforms that are looking at emissions right now. And I'm going to have him speak first. And the second is Tom Ingersoll, who's been the CEO of Skybox. He has been working at McDonnell Douglas, and he's now the co-lead at MethaneSAT. And so I'm going to have them talk to you about just this incredible new technology and how it's going to help us to solve the climate problem. So Stephane, why don't I begin with you to talk about GHGSat and kind of this emerging platform and what it's doing right now.
Well, thank you. And so maybe I'll start from there just with a quick introduction to who we are and what GHGSat does. So we have 3 satellites in orbit today, and we use those to monitor greenhouse gas emissions from industrial facilities around the world at very high resolution. So we're designed specifically to go pick out emissions from individual oil wells, from individual landfills, from coal mine shafts, from any individual source in the world. And so we first launched our first satellite in 2016, so we've been at this for a little while, and we launched 2 more satellites during the pandemic, so one in early 2020 and one in 2021. And we've now absolutely nailed it. The technology does exactly what we always wanted it to do, so now we're building them in batches. We have 3 more going up this summer in June, and we have another 6 more that are going to be launched in 2023. So with that, the goal is to be able to monitor places like the Permian Basin once a month, and for any company, and be able to really see what's going on with individual operators right down to individual oil wells. And like I said, we can do that for coal mines, for landfills, and for any other industrial source. So I'd like to touch on a few more points in very brief introductory points. The other key distinction you'll see between what Tom's going to talk about and what we do is that we're a for-profit company. We're a commercial entity. And in the satellite business, that's not always obvious. There are obviously publicly funded satellites. So obviously NASA, the European Space Agency, the Japanese, and others have launched satellites as well that monitor greenhouse gas emissions. But they do it to monitor the whole atmosphere all the time and to inform scientific models and UN models, for example, for temperature changes since the beginning of the Industrial Revolution. But they don't do it to identify individual sources. So the 2 are complementary. Ours that look at really high resolution, and the global ones that are operated by space agencies. Then there's philanthropically backed satellites like EDF's MethaneSAT that again is complementary to what we do, looking at somewhere in between the super high resolution that we do and the global mappers that are launched by space agencies. But as a commercial entity, really, we have to find that balance between generating revenue by serving customers and providing monitoring services for customers. And customers can mean operators and governments, and frankly, anybody who wants to buy data will happily sell it to them. And yet, at the same time, drive for action. So speaking of action, and I'll try to wrap this up really quickly, we just put out a report last week about everything we saw in 2021. So we measured hundreds of thousands of sources with our satellites last year. We detected 143 million tons of carbon dioxide equivalent last year with our satellites. We saw that about 50% of it was from oil and gas. And we saw that, as you might imagine, all over the world, but the leading sources were Central Asia, North Africa, Middle East, yes, the Permian Basin, and then also from landfills and coal mines around the world. So it's frankly now the age of transparency, of being able to see emissions anywhere in the world is here today. This isn't just a future thing anymore. It's here now. And we're going to have more than twice as much data just within a few months. We're launching in June 3 more satellites. So really, it's a very exciting time to bring that amount of data to bear on understanding where the issues are and where the opportunities are in climate change. So maybe I'll land one last point, which is, all the technology is great. All the AI is great that backs up the satellite data. We also fly aircraft instruments, so we have tons and tons of data. 95% of what we measure is not acted upon today. 95%. The challenge is action. And that's what I'm really hoping this group can help drive and motivate, not just in the US, but internationally, how we can use not just our data, but all data that's available for measurement of emissions to drive action. It's a really complicated subject, but obviously at the end of the day, it's what matters. So I'll leave it there.
That's perfect. Thank you, Stephane. So MethaneSAT is a really exciting project that is really doing 3 important things. Our objective is to, as Stephane said, not just to build a system, but to create action. So our goal is to reduce emissions from the oil and gas sector by 45% by the year 2025 and by 70% by the year 2030. So we have an action-oriented goal because in reality, that's the most complicated thing that we're doing. I like to tell people that the MethaneSAT program is doing 3 things, and this is in increasing order of complexity. So the easiest thing we're doing is building a very high-resolution infrared spectrometer satellite that will detect methane from a global perspective, as accurate as any satellite ever built, and do it at a very small fraction of the price of any satellite of its kind ever built, literally a factor of 10 less than a traditional science satellite. So that's the easiest thing that we're doing. The second thing that we're doing is we're building a data platform that will allow us to process in a very rapid way gigabytes of data a day that's going to be flowing from the satellite 24 hours a day, 7 days a week. I like to remind our scientists that this will occur every day, weekends, holidays, that data is coming down every day, and it all must be processed. A day's worth of data from the satellite has got to be processed in a day, otherwise we get a big backlog. So developing and processing very high resolution and important scientifically relevant data is key. Our data, if you think about it, has to be irrefutable, because if we're gathering data to measure and to provide transparency as to how operations are going around the oil and gas sector, they've got to believe the data. If they don't believe the data, we have failed. So that's the second most challenging thing. The most challenging thing that we're doing is what Stephane said, is the advocacy side, is that we've got a large group of folks that are looking at how we take this data and convert it to action. Environmental Defense Fund has learned over its history that data does not equal action. And so much of our resources are being placed into understand, okay, if we get these kinds of measurements in this particular basin or in this sector of this basin, how can we get those actors in that area to actually make a change? And what are the various levers? And what we found is that the levers required to take action in the Permian, in fact, in subsets of the Permian, are different than what you find in the Marcellus, than what you're going to find in the Middle East, than what you're going to find in East Africa, et cetera, et cetera. So putting together that advocacy plan, I'll call it the third leg to the stool, is probably the most challenging and the one that we're putting forth a lot of resources. Our system is going to be launched about a year from now, Q1 of 2023. We have Harvard University is leading the development of the science. That got back to our challenging point number 2. And we've got a really strong group of folks that are helping on our advocacy side. So we're excited about the potential of being able to provide transparent data. Our data platform will allow all of the data to be made available on a non-commercial use basis. So it'll be very transparent to the world. So the world will be able to see who is generating clean methane and who is not meeting their production goals.
Thank you both so much. Really fascinating. I think it's really interesting that we're going to have government satellites, we're going to have commercial satellites, and very soon we're going to have a nonprofit satellite. It used to be we had 0 satellites monitoring emissions. This is kind of a revolution that's happening now in this space. Tell us a little bit about what you see. So we see a ton of promise and really a revolution. What do you all see as some of the challenges as you move forward, just technologically? I've already gotten a question from one of the audience members about glint mode, but tell us a little bit about, a satellite can't see everything all the time. So I think the audience would be interested to know, like, what can the satellite see and not see? How does that work? We've got some techies here who want to know about satellites.
I'll just do it real quickly. We can only see with reflected sunlight, right? So we can only see the sunlit portion of the world. We see around the equator very, very well. We don't, in the northern hemisphere in the winter, we don't see it a whole lot because the days are short. But we can't see through clouds. We can't see through a lot of haze and smoke. So there are some limitations. However, the satellites they orbit around the poles, and they have a 90-minute orbit. And so over time, we do get to see the entire world. So long as there's no clouds, there's nobody that can hide from a satellite. Doesn't matter what your political orientation is or the organization of your government, they can't hide. We get to see everywhere on the planet.
And it's the exact same thing for our satellites. Maybe I'll answer the question a little differently, which is, and it's part of the reason why collaboration between different satellite systems is so important. Even with all the satellites that are planned over the next 10 years in methane, we're still going to be seeing only a fraction of the surface of the Earth every day, right? And right here, I'm talking high resolution satellites. And so you always have, by definition, a sparse model. You always have a sample of all the actual emissions that are going on out there. And you have to have a good enough sample that you can statistically project from that to get an idea of what's going on everywhere in the world. So it's there's different approaches to this. Of course, MethaneSAT is going to have a different ability than GHGSat satellites to be able to get that full view of inventories. But extrapolating to global and country level inventories is going to be a significant challenge.
I can just toss one point in there. I think the thing that make it clear is that the various classes of satellites, and I use an example of a camera that we all can understand. So there's a telephoto lens camera, right, that allows you to see very precision, but in a very small area. Think about your telephoto lens, right? There's a 35mm lens that lets you get a pretty good perspective. And then there's a wide angle lens that allows you to see a very large swath, but not with very much accuracy. And there are satellites flying that do each one of those. The GHGSat system is more like that telephoto lens. It's kind of that soda straw, but high level of definition. The Techonomy satellite flying out of Europe, it's a European system. It's a wide angle lens. It sees thousands of kilometers. And then the MethaneSAT system will sit in between them, looking at a broader swath, more focused on basin level methane identification. So it does take a system of satellites that are complementary to really get the full picture.
I want the audience to get ready with your questions because I'm going to ask one more question of the panel, and then I'm coming to you. In terms of action, my understanding is that both of your satellites are going to be participating in a larger platform that will help to aggregate some of this data so that, say, the UN or the European Union or governments can look at this data in aggregate. Could you all talk a little bit about this platform, which is called IMEO, and how that will help to prompt more action?
Sure, why don't I go first on that one? So we announced at COP26 that we're donating all of our data from our satellites to the UN Environmental Programme's International Methane Emissions Observatory, IMEO, and we'll do that for the next 5 years. And we're doing that to basically help provide global transparency. And we've done that in a way that allows us to maintain the commercial value of our data. So this is not for commercial use, right? And it's also to be used at an aggregated level so that it can really inform country level inventories and even regional level inventories and really get to an apples to apples comparison of emissions everywhere in the world. So we feel that's a very important part of our mission is to not only help operators understand their emissions, help regulators understand where the opportunities are for reducing emissions, but also contribute to the international community and understanding the full picture of what's going on around the world.
Yeah, man, and obviously the data from MethaneSAT will be available because it's going to be available to the public for non-commercial use, so it will feed into Mayo. I think the other important piece of that is that it does allow all the data from the various systems to overlap so that there's going to be consistency of the data results, right? Because if his system shows the emissions are a fraction of what our system shows or vice versa, then all of a sudden the operators kind of they have a get out of jail free card there because, oh, well, nobody knows what the real results are. So having a central repository that can provide consistent results makes it much, much more challenging for operators to challenge the veracity of the data.
All right, I think we have a question right here. And one of the other things I think that's interesting is both you all are using also drones and other things to help flight overflight to collect data so that you can be getting other ways of gathering information and data, as well as using existing databases. So I think the other thing is that there's multiple threads of information that you all are using in addition to the satellites, which I think is really an intriguing overall picture. All right, go ahead. Please let us know who you are and your question. Thank you.
Hi, I'm Kalee. I am a scientist at Park working on climate and AI research. So I've actually worked on GHGSat satellites on Clara and Iris, so it's so glad to see you. So one question I had, which kind of you addressed, is both of these high resolution satellites are doing targeted observations, right? So there is a trade-off between resolution and coverage. One idea that we have been working on is like, how can we use some of the GHGSat with Techonomy and use AI to enhance the resolution so that we can extrapolate to other areas. But that requires all of these satellites to work together and do the global coverage at a consistent pace. Like, is there something going on in the backside? I don't know, like, if you're working together on making that happen.
Yeah, so we are already working with Techonomy, with the European Space Agency, in what's called a tip and cue. So using the camera analogy, when we get the wide angle view from Techonomy, it'll tell us, oh, there's a blob over here that looks like it's methane. Could you go take a look see what's going on? And we'll focus our telephoto lens there and say, aha, that's the landfill that's over here. And we've been doing that now for 3 years with Techonomy, and they've helped us find hundreds of sources around the world. And there's actually been several peer-reviewed scientific papers published about this, including a really crazy in Turkmenistan I can tell you guys about afterwards if we have time. So there's really a great opportunity for satellites to coordinate that way. And actually, I very much look forward to doing that with MethaneSAT, because we'll have, again, a complementary ability where if MethaneSAT sees something that doesn't quite have the resolution to pick out the exact source for, we can go in and find that. So being able to interlink our systems so that we can have a timely tip and cue, especially in an environment where there's a lot of intermittent emissions, where not all emissions are just constantly emitting. They come up and they stop, they come up and they stop. So having really timely links between the systems so we can really go look quickly is really important.
We are committed to working together because we know we're more powerful together. There's no doubt about that.
Tom, do you want to just talk quickly about methane air also a little bit, and just a little bit about what you've seen with the methane air work?
Well, I think Kaylee's point earlier about satellites can see a lot, right? And they're very, very powerful from a strategic global perspective, but there are limitations about what they can see and when. And so you can use aircraft, and I know GHGSat's doing the same, to sort of fill in the gaps. So we do have a system we call methane air that has been flying around. We're in the early phases of deployment, but what's been interesting as we've done some flying over the Permian, over the Uinta Basin, I think the emissions that we have found are significantly greater than anybody really expected. The Harvard science team, actually, we're flying over the Uinta Basin, and we were banking around northern Salt Lake, and they weren't expecting to see any emissions, and they were banking around and coming around, and they weren't even expected to be able to process the data through the banking maneuver. But what they found is there was an oil refinery up in that area that they expected to be pretty clean, but it turned out to be emitting thousands of kilograms of methane an hour. It was kind of shocked everybody. So we're finding in just some of the small amount of work that we're doing, and I think it ties to what Stephane said, is that there's far more emissions out there than people are reporting. And methane is a great source of energy if it's used wisely, because it burns cleanly. But if you aren't burning it properly, if you're not managing it properly, if you're flaring it without lighting the flare, I mean, it's pretty messy, and I think that's what we're seeing.
Well, and if I can just add, and this is really an indirect comment on recent geopolitics, the amount of methane emissions we're seeing just in the fourth quarter of 2021 and now in the first quarter of 2022 is orders of magnitude different than what we were seeing before. I mean, some of that might be pandemic related. I strongly believe a lot of it is geopolitically related. So we're seeing really, really large emissions in the Permian Basin now, like far greater than anything we've ever seen before. It used to be we'd see maybe 1 or 2 emissions per satellite pass. Now we see multiple. And we're seeing that all over the world, actually. And we're actually seeing very significant increases in coal emissions as well, that I would argue is related.
I know I have time for one more question, and I've got one right here. And if it's fast, I have time for 2. So
right, thanks. I'll try to make it fast. Derek Pancras with Deloitte. It sounds like both of these efforts are largely focused on the oil and gas sector, but obviously methane, big problem in ag and food systems. Can you talk about the applications or limitations of the technology for food-related methane emissions?
So just go quickly. Our primary focus has been oil and gas, just because it doesn't have to do with the capabilities of the satellite. It's that data to action piece, and our focus has been getting action from the oil and gas sector. But we are partnered with the country of New Zealand, who is focusing on ag, and their goals are going to be driving action on the agriculture sector. So we can look at oil, and we look at emissions regardless of the source, right? But gathering the emissions and measuring the emissions is just a fraction of the problem. It's converting that data to action, and that's really where we need some expansion.
okay, I have the most important person in the room to ask a question.
No, I do have a question.
I can go over with you.
But you actually have time on the clock. You're extremely obedient. But my
That's
question
the first
is,
time I've ever heard that in my life.
well, good. What has been the reaction of the oil and gas industry to this whole trend? I mean, obviously they must hate this. Are they trying to stop it? What are they doing?
A whole range of reactions, actually. We get everything from what I would call the more forward-looking players that actually, as soon as we give them information, they jump on it and go fix it. And in fact, they want the data faster, so that they will go fix a leak within 48 hours as soon as they get the information. And that tends to be the bigger ones. They have committed to pretty stringent, at least public commitments to reductions, and not all of them, but many of them will act on it. At the other extreme, when I have personally made phone calls based on plumes that we've seen, where on the other end I get, that's not us, thank you, goodbye, click. And that's because they acknowledge, as soon as they acknowledge that they have a leak, they actually have to do something depending on the jurisdiction. And so they just don't want to even acknowledge that they have a leak, and that's the end of it. So it is a very diverse group with a lot of different motivations, and we've gotten reactions across the spectrum.
It might also be worth mentioning that similarly amongst governments, right? That there's been a range of reaction amongst governments as well. Some really want the information. Some of them are partial or full owners of oil companies, and the financial sector, which I think is the other piece we only have 45 seconds to get to, but a lot of interest there as well in having this kind of information because of the interest in ESG in terms of investing.
I'm sorry, I have one more question. I'm sorry, Tom, go ahead. But Russia, I think it was the Journal, did this incredible investigative piece about all the methane leaks in Russia. I mean, phenomenal. And here we now have Russia essentially becoming an outlaw nation. They're not going to do anything we say. How is that going to fit into this?
Yeah, that one's
I'm the
you,
moderator.
Kalee.
I'm the moderator. Pass, hard pass.
Yeah, that's a hard one, right? The world is coming to grips with that as we speak. It has been said that Russia claims to be the cleanest producer of natural gas in the world. There's no data to support that or refute that.
I've got data to refute it.
Yeah, but they don't believe it, right? But it's a challenge. Russia's a challenge.
Yeah, I don't have a lot to add there, but I would say that we are tracking many, many, many sites across Russia, and the data is being acquired by parties that are interested in using that data for all kinds of reasons.
Well, let me thank you all and the panel for an incredible discussion. I know we will be following up. Please feel free to ask questions afterward and to reach out to our esteemed panelists. Thank you so much.